Okay, guys, this is Smart Knob team, and I am Hongyi, and this is Houxuan.
So our project is to build a knob with BLDC motor providing like real haptic feedback. We 3D printed all the shells and cases and inside sporting parts. We have built a set of final PCBs, the BLDC motor on board, realizing haptic function last week. For ESP part, we use Python and C++ for controlling motor and screen, also the web server. Our final goal is to build a full functional, good-looking knob, which can be put into actual use and add an additional function at any time.
So now we have just finished our milestone 4, and in milestone 4, we managed to use the website to send data to the smart knob, and thus it can change the mode of the knob. We now have two modes. The first is the haptic mode. We have 7 slots that can provide haptic feedback, and the other is non-haptic mode. That is, it can rotate smoothly. So for the next milestone, we plan to add more modes to the knob, and also we need to write a better web page, a better user interface.
So about design choices, when building final PCBs and polishing our firmware, we decided to dump some of the components like ambient light sensor, the magnetic encoder, since the better one from MediaTek still have not arrived. So that's making it simpler and more compact. Also, we changed the ESP32 Pico and to the one we use in E326,
326, yeah.
which is room 32E. So, but the overall design choice has not changed.
And the interviewee said that to investigate more on 3D printing parts, and we can also make the grip feel better, since this is the main function. So for there's one thing new to us, that is we can make the ESP32 request data from the website through a WebSocket. The first we need to do is that we need to create a global variable data in the server. That's in the Python code. And then the server need to get data from the normal client, that is the user interface. And then the ESP32 can open a WebSocket and to request the data from the server. The server can send the data after the ESP32 request, and the ESP32 can process the message from the server and get the data from the website. So we have a short video illustrating this function. This is also the main change in our milestone 4. This is the first revision of our smart knob. So the main improvement is that in our last prototype, we could only send data from the ESP32 to the website. But now we are able to send the data from the website to the ESP32, so that we can switch the mode of the knob from the website. As you can see, now we are at current mode. We are at mode 0. This is the calibration mode. And when we touch the switch mode button, it will go to mode 1, which is the haptic mode. In that mode, the knob is working in a haptic mode. You can see we can feel resistance when we want to rotate the knob. And when we press the switch mode button again, we go to mode 2, which is the non-haptic mode. So you can see we can rotate the knob smoothly. And when we hit the button again, it will go back to the haptic mode. And when we press the calibrate button, it will go to mode 0, which is the calibration mode, and it will go back to the 0 position. And now we can switch mode to mode 1 haptic or mode 2 non-haptic as we Okay, so now we have two questions for you guys. The first is that can you come up with some other modes that we can implement besides those that the knob already has or is going to have, that is the haptic and non-haptic mode and the on and off mode that we are going to implement in the milestone 5. And question 2 is, do you have any idea how the server can render .css and JavaScript file? Because now we only have the HTML file. We want to add some styles and functions to that website. Okay, thank you for watching.